The kidneys are the main structures of our body, responsible for detoxification of our blood. In order to perform this function, blood filters in the nephron, the main structural and functional component of the kidney.
The blood is drained into the kidneys through the renal artery, which divides progressively as you see until it reaches the efferent arteriole that opens in the glomerulus. The glomerulus is a fenestrated blood capillaries that depend on pressure gradient in the efferent arteriole to do filtration. When the blood enters the glomerulus, it's filtered into Bowman's space. The filtrate drains to renal tubules, where most of it is reabsorbed except toxins. The pressure inside kidneys vessels depends on the systemic blood pressure. An increase in arteriolar pressure increases the volume of filtered blood per unit time, GFR, and so increase in urine formation.
The GFR is regulated by extrinsic and intrinsic mechanisms that work together in order to keep the blood pressure normal. This happens by increasing or decreasing blood pressure with the help of vasodilation, vasoconstriction, and decreasing blood volume. One of these mechanisms is the renin-angiotensin mechanism. For example, if someone had an accident, he would lose lots of blood, so his blood pressure decreases, hypotension. This leads to the activation of the renin-angiotensin mechanism, which acts on the kidney's blood vessels in order to normalize blood pressure.
The juxtaglomerular apparatus is a specialized region of a nephron where the efferent arteriole and the distal convoluted tubule come into direct contact with each other. The juxtaglomerular apparatus is composed of three types of cells: juxtaglomerular cells, macula densa cells, and mesangial cells. The juxtaglomerular cells acts as mechanoreceptors. When the blood pressure is low, it secretes renin, which leads to the activation of the renin-angiotensin mechanism, which acts on blood pressure amelioration. Macula densa cells acts as chemoreceptors or osmoreceptors. When blood osmolality is high, it constricts the efferent arteriole, which decreases blood flow to the glomerulus, and so decreases the GFR. Mesangial cells don't participate in filtration pathway,